Hello class, welcome to the lesson 2.4 homework video. So we're going to go over the homework problems from Savas online. So let's look at the first question, which involves slopes for two lines. All right, so it says that you want to compare the slopes of the lines for y is equal to f of x and y is equal to g of x. Okay, so let me clarify. In algebra, we usually have what we call a function. And so here we have two functions, okay? This is pronounced f of x, this is pronounced g of x. And what that basically says is that you take an input, which is x is my input, and then I get an output, and that output is my f, or f of x, what we call f of x. And that's the same thing as y, okay? So if you see f of x or g of x, that's just simply y. Remember that y is my output, x is my input. Okay, so that's usually how these things work. And so when you see f of x, this is the same thing as the y coordinate. G of x, that's the same thing as another y coordinate, but it's for a different line. It's not for the same line, okay? Because you have two different lines going on here. And you want to figure out if this line, f of x and g of x, are parallel or not, okay? So you have two different lines that you're dealing with. And so that's why we have so many columns, okay? All right, so what we want to do is, well, first, we want to determine the slope and to determine if they're parallel. So remember that slope is equal to the change in y over change in x, or y2 minus y1 over x2 minus x1. So that's the definition of the slope. That's how we calculate it. So right now we're going to focus on the f of x, okay? So if we were to focus on f of x, only f of x, not g. So ignore g for a second. So now these are my y values. So you're going to pick any two y values from this column, okay? So let's say that we picked 22 and 50. Well, in this case, 50 would be my y2, 22 would be my y1. Okay, so let's go ahead and say, well, the slope has to be equal to y2 minus y1. So it's 50 minus 22, right? 50 minus 22. And so my x values that correspond to that are these guys right here, right? So that x value corresponds to that output of 22. This output of 50 corresponds to my input of 2. And so I have to use those values. So this is going to be my x2, this is going to be my x1. And I have to do it in that same order. If I don't do it in this order, if I mix the order of x and then y and I reverse them, then it's going to change the answer. So I can't call this x1 all of a sudden when I call this y2. This is not going to work. Okay, so keep the same order for x as you would for y. So we have here 2 minus 0. So that's my x2. So 50 minus 22 is 32. 2 minus 0 is 2. 32 divided by 2 is 16. So my slope is 16 here. So now let's do the same thing for g of x. So now completely ignore f of x because we're not concerned with that line anymore, okay? And so let's look at two y values for g of x. You can choose any two y values that you want. So let's choose 53 and 57, or 67. So let's call this y1, let's call this y2. So we have 67 minus 53. We have here slope equals 67 minus 53 over. And so now we want to use the x values that correspond to that, which are these guys, right? So this is going to be my x2. This is going to be my x1. So it's going to be 3 minus 2 on the bottom. So we have 67 minus 53, that's 14. 3 minus 2 is 1. And so we got 14 as my slope. So if you compare these two slopes, well, we know that they're clearly not the same, right? They're not the same. And because they're not the same, that means that the lines that we're looking at here are not parallel, right? So this means that the lines are not parallel. The only way that two lines are parallel is if the slopes are the same. And so we're going to say, well, the slopes are different, so the lines are not parallel. And we're going to identify, well, the slope of this is 16, the slope of this is 14 for this particular example. That's it for that problem. Okay, so we're going to do the same thing here, just another problem. So again, pick any two y values. Let's do this for the f first. So slope, this is, remember, the m is a symbol for slope, so I'm going to use m instead of writing out slope. So slope is equal to, let's pick these two, 13 minus 10, and then divided by, now you got to do these two, 2 minus 1. 13 minus 10 is 3, 2 minus 1 is 1, 3 divided by 1 is 3. Now let's look at g. We can do this a little faster now that we know what we're doing. Let's say we pick these two values. So 22 minus 4 over, and let's choose these two because they correspond to that, 3 minus 0. 22 minus 4 is 18, 3 minus 0 is 3. 18 divided by 3 is 6 in this example. And so we see that they're not parallel either, so right? So they're not parallel. So if they're the same, then we say that they're parallel. Otherwise, they're not. And that is it for this particular problem, guys. So we'll clearly say that they're not parallel because the slopes are different. All right, so write an equation of the line parallel to the given line that contains C. So this time we have an equation of a line, and we want to figure out the line that is parallel to that. So we want another equation, some kind of equation, where the equation of that line is parallel, the line of that is parallel to the line of this. So remember, lines that are parallel have to have the same slope. So because they need the same slope, that means, well, first off, we need to identify this slope, and then we can use that same slope in the new problem, right? So what's the slope of this guy? Remember, y is equal to mx plus b is the slope-intercept form equation for a line. Remember that in this equation, m represents the slope, and b represents the y-intercept. Slope, remember, is the rise or run. The y-intercept is where the graph crosses the y-axis. So if we have something in slope-intercept form, we can easily pick off the slope from the equation, which we do. We have this is in slope-intercept form. So clearly, this is my m. M is equal to -2 because it's right in front of x, right? So mx plus b. So m is -2. Now, because the slope here is -2, that means the slope of the parallel line is also going to be -2, right? So we're going to use that slope. So we have here. So we're going to use this slope right here. Y equals -2x plus b. So that's our equation so far. We got to figure out what b is. Once we figure out what b is, then we're done because we got the equation of a new line that is parallel. Okay, so how do we get b? You have to plug in your x and y that they give you, which is right here. So remember, they give you this coordinate for a reason. This coordinate tells you your x value, and it tells you your y value. So we can plug those in. So if we know y is 5, well then this is 5. And we know that x is x is 3. So we're going to use that here. Color code that, and it's blue. So x is now 3 plus b. So you can see here we only have one unknown now. We can solve for this unknown. We got 5 equals -2 times 3. This is multiplication right here. We have to multiply those two. -2 times 3 is -6. Now if I want to solve for b, I have to get rid of -6, so I have to add it to both sides. So 5 plus 6, that's 11. So b is 11. So we can plug that in, and we got our equation for our line. Our equation of our line is y equals -2x plus 11. This was my slope earlier. And we'll use purple for this. That's my y-intercept. And you're literally going to type that equation right here. That entire equation. All right, so now we want to do the same thing here. Find the equation of the line that is parallel and the equation for the line that is perpendicular. Okay, so First off, notice here that we do not know the slope right away from this. The reason we don't know the slope is that that equation is not written in slope-intercept form. That equation looks nothing like y equals mx plus b. Okay, so first off, we have to convert this to y equals mx plus b so that we can pick off the slope from the equation. Okay, otherwise we don't know what the slope is. So we got to figure that out first. Once we figure out that slope, then we can use that slope for the new line that is parallel to it. Okay, so let's do that first. So we need to pick off the slopes. We need to convert this to slope-intercept form. So that's my first step here, is converting that to slope-intercept form. In order to convert that to slope-intercept form, you have to solve for y. You have to get y by itself. And so you want to get rid of the outsiders first. So this guy is next to the y, and you don't want to get rid of him until last because he's literally right next to y. You want to get rid of the outside strangers first, and then get rid of the inside man. So we got to get rid of the 5x. And the way you get rid of outsiders like this is to add or subtract them. Now, this is a positive 5x, so I have to subtract him because I know that 5x minus 5x is 0, so that goes away. And then I have to do the same thing on the other side, of course. This goes away. We're left with negative 3. This is multiplication right here. This is negative 3 times y, okay? This is not negative 3 plus y. This is negative 3 times y. Okay, so keep that in mind. We don't write the multiplication there, but it's assumed that it's multiplying. So negative 3 times y is, now we got this negative number, which we cannot subtract with 15 because this is a variable and this is not. So we're going to rewrite the negative 5x, just bring it down, bring down the negative 15 next to it. Okay, bring down the variable first and then the number, just like I did here. Now, we need to get rid of the negative 3, keeping in mind that this is actually a multiplication problem. The only way I can undo multiplication is with division. So I have to divide both sides. So I'm going to divide both sides by negative 3 here. And that's the only way to get rid of this negative 3. I have to do the same thing on every single thing on the other side. So I have y equals negative 5 divided by negative 3. This is a double negative, so this turns into a positive. Remember, a negative divided by a negative is a positive. This is just a fraction, so leave it as a fraction. You can't really do anything with it unless you want to convert it to a decimal, which we will not. We got a double negative here, so that's positive. 15 divided by 3 is 5. So we got that as my equation so far. So now we can pick off the slope from here, right? Y equals mx plus b. Remember, y equals mx plus b. So we can clearly identify that the slope has to be 5 over 3. It's right before the x. And so that's my slope. My slope is 5 over 3. So now that we know the slope, we have to use that same slope for the parallel line, right? Same slope for parallel. So if we want the equation of the parallel line, which is what we're doing right now, we need the same slope. So I'm going to plug this in right here. So we get y equals 5/3 x plus b. That's what we have so far. And we need to figure out what b is in order to solve this, in order to get the equation of the line. So how do we figure out b? Again, use the method that we used the previous problem. We have to plug in for y and x, which based off of the coordinates that they give you right here. See, they give you these coordinates. So this is x, this is y. Let's use the same colors as last time. That's x, that's y. So y is 5, x is negative 4. So let's plug that in. 5 equals 5/3 times. This is multiplying, right? This is invisible multiplication. So negative 4 plus b. Now this one's harder because we're dealing with a fraction here. And, you know, if you're not very comfortable with fractions, basically anything, even if it's something elementary, looks complicated. And that's because you're just not comfortable with fractions. So once you're comfortable with fractions, it's really not so bad, okay? So here, if we want to multiply a fraction with a whole number, you have to convert the whole number to a fraction, okay? So put it over 1, multiply straight across, and then that's your new fraction, okay? So 5 times negative 4, that's negative 20. 3 times 1 is 3. That's my fraction. That's it. Multiply those straight across. Now, the hardest part of fractions that students, tend to not like is adding and subtracting fractions, right? Or just dealing with them in general, right? So if I want to solve for b here, I need to get rid of the 20 over 3. So I'm going to go ahead and add it to both sides. So now I need to add 20 over 3 to 5. How do I do that? Okay, so let's add 20 over 3 to 5. So we have 5 plus 20 over 3. So in order to add a whole number and a fraction, put the whole number over 1 so that it's a fraction too. Remember, you can't add fractions unless they have the same denominator. And so the common denominator here, you have to convert this 1 into a denominator of 3. And so I need to multiply this top and bottom by 3. And now they'll have the same denominator. You see, if I do it on the bottom, I have to do the same thing on top. I can't just unequally treat the fraction, right? I have to have equal treatment here. So now 3 times 1 is now going to be 3. And then so now I have the same denominator, right? And 5 times 3 is 15. And so now I can go ahead and combine these two fractions and I'm done. 15 plus 20 is 35. Remember, do not combine denominators when you're adding fractions, right? So it's going to be 35 over 3. So keep the denominators the same when you're adding or subtracting fractions. And so now we have the, let's go back to the problem here. I think I erased it. Okay. So now we know what b is, so we can plug it in right here. And we have, let's do that in purple. And so now our equation is y equals 5 thirds x plus 35 over 3. That's my equation of my parallel line. Parallel line because they have the same slope. Okay, so that's my equation of my parallel line. What if I want the perpendicular line? What if I want perpendicular? Well, that's another whole story. Okay, so if I want perpendicular, the slopes can no longer be the same here. Okay, so for perpendicular, slopes are not the same. If I know that my original slope is 5 over 3, then my perpendicular slope, which this is my perpendicular slope. My perpendicular slope has to be the flipped version of that with an opposite sign. Okay, so I have to flip the fraction. So now it's 3 over 5. And then I have to change the sign of the fraction. So this fraction originally is positive, right? And so I'm going to change it to a negative. So I change the sign, I change the fraction. And that's my perpendicular slope. And so when I do my y equals mx plus b, well, then I'm going to use that new slope. So I'm going to use this right here. We get y equals, use that new slope, x plus b. The y and the x are still going to be the same, so that's not going to change. Y is still going to be 5, and x is still going to be negative 4. And I don't want to use the same color here, so I'm going to use green here this time. Okay, so y is 5, x is still going to be negative 4 in the problem. Okay, so we have 5 equals negative 3/5 x plus 4. I'm sorry, this is going to be 4 plus b. Let me double check the problem. X was negative 4, right? Yeah, x was negative 4, not positive 4. Okay. So again, dealing with fractions again, right? So we got a whole number with a fraction. Put this over 1, multiply straight across. 3 times 4 is 12. 5 times 1 is 5. That part is done. I need to solve for b, so I need to get rid of this. So I need to subtract that on both sides. So I have to subtract 5 and 12 over 5, and that's going to be b. So 5 minus 12 over 5. Put this 5 over an invisible 1. I need to have the same denominator here. So I need to make this into a denominator of 5. The only way to do that is to multiply by 5. Whatever I do on bottom, I do on top. So I get 5 times 5 is 25. 5 times 1 is 5. Minus 12 over 5. Now they have the same denominator. You can go ahead and subtract. So 25 minus 12 is 13. So 13 over 5. Again, do not subtract denominators or add them. So we got b. Plug that in there. Let's use that as a purple b. So we got negative 3 over 5 x minus, or plus, sorry, 13 over 5. And so this is my equation of my perpendicular line. Again, it looks like a lot, but that's because I'm explaining everything. You should be able to do this pretty quickly if you do this with enough practice. All right. So write the equation of the line parallel and the equation of the line perpendicular to this line. So now that I showed you how to do this, I'm going to do this in a relatively faster pace. Okay. Convert this to slope-intercept form, and then plug it into y equals mx plus b. So I need to get y by itself. So what I'm going to do is I'm going to multiply this. I'm going to use the distributive property. This is called the distributive property, where I have a number on the outside multiplying against what we call a binomial, multiplying against two things that are adding or subtracting, two or more things. So you just multiply against everything. So 1/2 times x is 1/2 x. 1/2 times 7 is, well, put this over 1, multiply straight across. 7 times 1 is 7. 2 times 1 is 2. So it'd be 7 over 2. Equals y minus 7. Get y by itself, so I have to add the 7 here on both sides. Okay, so we get y is equal to 1/2 x plus whatever this is, right? Whatever that is. It doesn't really matter what that is, right? That could be anything. What matters is that we know the slope. The slope is whatever's in front of the x right here, whatever's before that x. Remember that it's y equals mx plus whatever, plus b, right? It doesn't really matter what that b is. What matters is if we can identify the slope, which we can. So the slope is clearly 1/2 without even having to do this fraction stuff, all right? So since the slope is now 1/2, that means that I'm going to be using that slope in the same equation, y equals mx plus b, for parallel. So let's do the parallel. So you plug that in there. So I'll just replace it just because so I can save a little bit of time here. 1/2 x plus b, and then replace y and x. So in this case, the point that they give you is, this is the point that they give you. This is x, and this is y. So 1 and -1. So y is -1. I'm just going to go ahead and replace this right now, just to save a little time, so I'm not, spending too much time writing stuff. Replace the x with, I think it was 1. Yeah, x is 1, y is -1. And 1/2 times 1, put this over 1. 1 times 1 is 1, 2 times 1 is 2. So it's 1 over 2. So let's replace this with 1 over 2. Subtract 1/2 on both sides to solve for b. So b is -1 minus 1/2. So put this over 1. Need a common denominator, so I need to multiply this by 2 to make it a common denominator. -2 times 2 is, -1 times 2 is -2. 1 times 2 is 2. So -2 over 2 minus 1 over 2. Remember, do not subtract denominators. Keep it as 2. -2 minus 1 is -3. And that is my b. And so my equation, y equals mx plus b, is y equals 1/2 x plus -3 over 2. And usually I don't like to write a plus. I just write, if it's negative, I just put a negative there. So that's my slope-intercept form for my parallel line. This is for parallel. Now, if I want perpendicular, again, I cannot use 1/2 as my slope anymore, right? If I want it for perpendicular, instead of using my slope of 1/2, I'm going to reverse it. And my new slope for perpendicular is going to be flip that. So it's 2/1, and then change the sign. So if it's positive, it changes to negative. And 2 divided by 1 is 2, so this is -2. So my new slope here is -2. Then I can plug it into y equals mx plus b. Plug that in there. So I'm going to do that right now. I'm just going to erase the m, replace it with -2. That's my perpendicular line. I need to find b. So remember, replace y with -1. I think it was 1. Let me see. Let's double check. Y is -1. X is +1. Y is -1. Replace it over here. Y is -1. X is +1. Just like that. So -2 times 1 is -2. We add 2 to both sides. So -1 plus 2 is +1. So b is 1. So now that we know b is 1, we can plug it into y equals mx plus b. So y equals mx plus b. That's my equation of my perpendicular line. All right, guys, let's go ahead and finish this off. So we have a line K passes through the points -7, -5, and 1, 19. A second line passes through the points -4, -16, and 4, 8. Is the line K parallel to line H? Why or why not? And so basically we're doing this is another slope problem. So let's call this x1, y1, x2, y2. And so we're going to do the slope for line K. Remember the slope formula is y2 minus y1 over x2 minus x1. And so y2 is 19, y1 is -5, x2 is 1, x1 is -7, so 1 minus -7. We got a double negative here, which turns that into a positive, so that becomes 19 plus 5, and 1 plus 7. So that's going to be 24 over 8. 24 divided by 8 is 3. So the slope of line K is 3. So now let's do the slope of line H using the same formula. So we have x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. Again, we have a double negative situation, so this turns into positive. 8 plus 16 divided by 4 plus 4. 8 plus 16 is 24. 4 plus 4 is 8. 24 divided by 8 is 3. And notice that these slopes are identical. So that means that the lines are parallel. Okay, so yes, the lines have the same slope, so they are parallel. Okay, last problem. So for the points A, B, and C, find the equation of the line through B that is perpendicular to AC. So basically we have, we were to kind of roughly map this out. 1, 2, 3, 1, 2, this is A. B is -3 and 7. So -3, 1, 2, 3, 4, 5, 6, 7. So B is around here. And C is 2, 7. 1, 2. Okay, so this is C right here. So we want to figure out the equation of the line through B that is perpendicular to AC. So this is my line AC. And we want to figure out a line that basically crosses through B, and that crosses this line at a 90-degree angle. Okay, so we want to figure out the equation of this red line. And so we're going to be using the point B here. B is the point that we use. And so this is X, this is Y. We're going to need that later. And we need to figure out the slope. So we need to figure out the slope of AC. And so we'll do that first. So this is x1, y1, x2, y2, just like we did in the previous problem, right? So let's find the slope there. Slope of AC. So we got y2 minus y1 over x2 minus x1. 7 minus 2 is 5. 2 plus 3 is 5. So this slope is 1. So that means that the perpendicular slope to that slope right here, which I'll use this as red, the perpendicular slope, you have to turn this into a fraction. So this is 1 over 1. You flip that fraction, it's still going to be 1 over 1, so it doesn't really matter. You change it from a positive to a negative because it's positive here, so it's going to be negative. If the original slope were negative, then of course you would change it to a positive, right? So here now the slope is negative 1 over 1. Well, 1 divided by 1 is 1. So the slope here is negative 1. So the slope of this red line that's perpendicular is negative 1. So we got that so far. So when we plug this into y equals mx plus b, which is what we're going to do now. So remember, y equals mx plus b. So let's replace this m, which is the slope, with negative 1. Let's also replace y and x with the coordinates for b. B is negative 3, y is 7. So now x is going to be, sorry, I said x is negative 3, y is 7. Okay, so x is negative 3, y is 7. Okay, so now remember, this is multiplication. Right here, you got to multiply negative 1 with negative 3. Negative 1 times negative 3 is positive 3. So we have here positive 3 plus b equals 7 on the other side. Subtract 3 on both sides, so b has to be 4. 3 plus 4 is 7. So 4 is equal to b. And so now we can plug that in to y equals mx plus b. So y equals mx plus b. And that's my equation of my line. So negative 1x plus 4. So if we look at the equations, looks like it's this one, negative 1x plus 4. There's an invisible 1 there, which we don't really need to write. So it's just negative x plus 4. All right, that is going to be it for the video, guys. I hope that you found this informative and useful. And as usual, I'll see you in the next one.